Hello students, in this video we are going to be working on right triangle trigonometry. There are several things that you're going to need here. There's actually two note pages. One is what you see here with this giant right triangle. We're going to use this page for vocabulary purposes. The back of this page looks like this, several examples, but also a place for a foldable, which is why you need the second page. The second page looks like this, but with margins on it. And what I've done here is I've cut off the margins. That's going to be step one. So you want to cut off the margins, and then you also want to snip the left side. You want to snip in between these triangles because we are going to build several flashcards like so. And then this foldable here with all these flashcards is going to go right into this place. And we're going to have a nice set of notes with some flashcards, notes, and examples. So pause the video for a second, cut the margin off this second page, and build your flashcards. Okay, now that you've built your note sheet, the other thing you're going to need is a really good calculator. What I mean by that is you are going to need a calculator that can handle some trigonometry. So I've got the classroom calculator here. And what makes this calculator so great is we have this trig button on the left over by the 7. Our trig button has sine, cosine, tangent, and sine inverse, cosine inverse, and tangent inverse. This is what we're going to need for our study of trigonometry. These other three trig functions you see here, cosecant, secant, and cotangent, and their inverses are a little more advanced than what we're going to be doing in this class. But you will need a calculator that has the three basic trig functions. So I recommend using the classroom calculator. I'm not sure if your phone calculator can do that or not. I do think Google Calculator has these functions on it as well. All right, so right now, first things first is we're gonna start this discussion by introducing some more vocabulary here, okay? So let's start out basic and build our way up. I do want to start by saying, guys, this is a brand new math topic. This is not something you've seen in any other math class, and it's going to feel new and it's going to feel different. But as we get in the practice of it, you're going to see that these pieces all fall together, okay? So we are doing a little tiny introductory unit on trigonometry. And trigonometry is very simply the study of triangles. The study of triangles. Now you can take an entire course at Salem called trigonometry. And that's a year-long course, so there's a whole lot to study about triangles. It's actually a pre-calculus course. It leads on to a lot of calculus activities. We're doing just the very basic introduction here. All right, so we're going to use trigonometry to solve right triangles. We just finished a lesson on Pythagorean theorem, so we're really familiar with right triangles, but here we're going to go a little bit deeper, okay? First things first is let's go ahead and label this right triangle. We absolutely should know at this point that the side opposite the right angle has a very special name. The side opposite the right angle has a name called the hypotenuse. So go ahead and label this extra long side on the triangle. It's the longest side of the triangle. This is the hypotenuse. We also know that the two sides that are not the hypotenuse, which are the two sides that line the right angle, are called legs. Okay. What you're going to find in this discussion we're having about trigonometry is that those two legs have a more detailed name. But it all comes from this weird symbol you're seeing down here in the corner. This angle down in the corner is called our angle of perspective. The symbol that you see here is a Greek letter called theta. You know, Pythagoras was a great Greek mathematician, so we're still using the Greek letters, and this letter is called theta. And theta represents the angle of perspective. Okay, so the angle of perspective is kind of a funky name, but we're thinking of it as kind of like an eyeball, okay, the way in which we view this triangle. So if I was here at this vertex viewing this triangle through the lens, through the angle of perspective, I would be able to describe these two legs more detailed, in a more detailed way. I would describe this leg that's all the way across the triangle and out the other side. I would describe that as being opposite of the angle of perspective. So we call this the opposite leg. So yes, it is a leg, but it is now called the opposite leg because it is opposite all the way across from the angle of perspective. So we've got the hypotenuse that's across from the 90-degree angle, and we've got the opposite leg, which is across from the angle of perspective. So what does that make this second leg? I'll highlight it in blue. Well, this leg is attached to the angle of perspective. It is next to, it is beside, it is adjacent to. It is called the adjacent leg. So now each side of the triangle has a very specific name, and each side of the triangle's name represents where they are. We've got the hypotenuse, which is across from the 90-degree angle. We've got the opposite leg, which is opposite from the angle of perspective, and we've got the adjacent leg, which is adjacent to the angle of perspective. Okay, so I just want to make a little side note here while we're working on vocabulary. I'm going to draw a second little triangle. And I want to see what happens if the angle of perspective moves. Okay, so I've drawn my triangle in the same direction, the same orientation as this original one. But instead of the angle of perspective being at the bottom of the triangle, I'm going to move it to the top. And I want to talk about how that changes the position of these legs. Okay. Well, first, most important, the hypotenuse has not moved. Remember, the hypotenuse has to be across from the 90-degree angle. So the hypotenuse is still here. Okay. But some things have moved. The legs have switched. Remember, we have an opposite leg and we have an adjacent leg. Opposite means it's across from or on the opposite side of the angle of perspective. So now the opposite leg is this vertical piece. And the adjacent leg, which is adjacent to the angle of perspective, is this top horizontal piece. So as the angle of perspective changes position, the opposite leg and the adjacent leg might also change position because they are dependent on where the angle of perspective is. So just keep that in mind. It's very, very, very important that we're able to accurately identify the parts of the triangle before we move forward. So this should be all the vocabulary you need for this lesson. You'll need to absolutely be able to recognize where the hypotenuse is, the opposite leg, and the adjacent leg, and be able to identify the angle that we're either solving for or the angle that we're using. Okay? All right, flip over and grab your foldable note sheet. Okay. I think what I'm going to do is just tape this into place. If you have glue, that's probably even better. I'm just home tonight and I don't have any glue as I'm making this video, so I'm just going to tape this into place. Alrighty, line it up, tape it in place, and now I've got like a three-fold note sheet here going across. I also have 3 different flashcards to use. Okay, and all this space is going to be for us to try to understand the difference between the 3 trig functions. Let's go back over and look at our calculator one more time. Remember, I hit that trig button, which is directly beside 7, and we've talked about that we're using the sine, cosine, and tangent buttons in our calculator, and these are functions that your calculator has been programmed to use. So we really need to talk about the difference between the sine function, cosine function, and tangent function. So that's what I want you to label these 3 doors on your flashcards. We've got sine, that's spelled S-I-N-E. In our calculator, they just abbreviate it to S-I-N, but it's S-I-N-E. We've got cosine, and finally we have tangent. Okay, so we're going to be trying to think through and compare the difference between sine, cosine, and tangent functions. Well, it's a good idea to look at all 3 at the same time. It's also a good idea to try to separate them very clearly in your mind. If you look at our examples, if you're just peeking at the examples, they kind of all look the same. Sometimes I'm solving for x, and when I'm solving for x, it's representing a side of the triangle every single time here. Other times I'm going to solve for theta, which is that angle of perspective. So I'll be solving for an angle measurement. Okay. The thing that's different about all of these examples is the placement of the numbers. Okay, I want you to really take a peek with me here. If we look at these first 2 examples, okay, we have our angle of perspective that's given. And then the positioning is, we might be looking for x as the hypotenuse across from the 90-degree angle. And then we're being given a 50 that represents the opposite side. And that's true of both of these. I've been given 20, which represents the hypotenuse, and I've been given 11, which represents the opposite side. Okay, well, when given a hypotenuse and an opposite side, that's where we're going to be using the sine function. All right, before we start taking notes and doing any work, let's compare it to the next set of examples here. In the next set of examples, look at what you're given in comparison to this first set. We might be finding x. In this case, it's on the hypotenuse again, across from the 90-degree angle. But this time, I'd be finding x in relationship to the adjacent side, adjacent to the angle of perspective. Or if I'm finding an angle, I'm still looking at the hypotenuse across from the 90-degree angle, and the adjacent leg that's attached to the angle of perspective. So cosine is going to pair up with this given situation where we have a hypotenuse and an adjacent side. And then there's one more combination, okay? The third combination is we aren't given the hypotenuse at all, and we're not being asked for the hypotenuse at all. Instead, we're working on problems that have an opposite side, a leg that's opposite of the angle of perspective, as well as an adjacent side that's connected to the angle of perspective. So here we have an opposite and an adjacent. Okay, and that's true if we're solving for the side or if we're going to be solving for this angle. It's still working on the opposite and the adjacent values. So we have these three trig functions, and everything kind of looks the same, but what's really happening is we're going to use a different trig function depending on what's given in the picture. So let's try to make that super clear, okay? Let's dig into the notes lab now. Let's start with sine. Okay. On our triangle, we're going to use sine if we're dealing with the hypotenuse. So I want you to label the hypotenuse again. Told you it's all about recognizing and labeling. Hypotenuse are always opposite of this right angle. Okay. And that is going to pair up with the opposite leg. The opposite leg is the side that's across from, all the way on the opposite side of the triangle. So if we're working on a sine problem, it is because we're working with the opposite leg and the hypotenuse. Okay, so to find a side value, here's the setup. Now this is brand new, so take your time writing it down because you're going to need it. We're going to take the sine function of theta, which is our angle. Remember, that's our angle of perspective. That's the view in which we're viewing this triangle. So the sine function applied to the angle is going to be equal to the ratio of these two sides, the opposite leg over the hypotenuse. Now don't go too fast. Make sure you write that down really well because that is the meat of what we're doing here. That is super crucial to understanding how to solve. We're working with sine because we're working on the opposite leg and the hypotenuse. In order to solve for one of these sides, whether we're solving for the opposite side or the hypotenuse, we need this equation. Okay? So let's see what that looks like over here in the example. 25 is our angle of perspective. That's theta. Label that theta. Our hypotenuse is across from the 90-degree angle. That's x. I'm going to label that h for hypotenuse. 50 is across from the angle of perspective, so that's our opposite leg. I'm going to label that O for opposite. So to plug all of these values into this formula, it would read like this. Sine of the angle of perspective, which is 25, is equal to the opposite length, opposite is 50, over the hypotenuse length. And our hypotenuse is what we're trying to solve for. That's our x. Okay. So we've taken a triangle and we've turned it into an algebra problem. And here's where you really need a good calculator, because we need a calculator that can apply sine to an angle measure of 25. Okay? Well, algebraically to solve this, I think the absolute easiest thing to do is to turn this into a proportion and do a cross multiply. You did a whole unit on cross multiplying. So I'm going to drop a 1 underneath this sine 25, and I'm going to cross multiply. This would be sine 25 times x is equal to 50 times 1. Now here's where my calculator's coming in handy. I'm going to switch screens. In the calculator, okay, under the trig button, I'm going to choose sine because I'm working on a sine triangle. And sine of 25 is this very irrational number. Now our calculator has rounded this for us, but I'm going to write out all of these decimals. So I'm going to write out 0.422618. 0.422618. If you're not getting the same decimal when you type in sine 25, your calculator may be set to a different mode called radian mode. If that's the case, just bring it to me and let me check it. And let me see if I can get it into the degree mode, since we're measuring our angles in 25 degrees. I'll check that for you, okay? So back over to my work page here. Sine 25 is 0.422618. Well, I'm saying sine 25 times x is equal to 50 times 1, and 50 times 1 is just 50. And now I have one more algebra step in order to solve for x. 0.422618 times x equals 50 can be solved by dividing by 0.422618. If I divide both sides by 0.422618, I will get x all by itself, and I'll know how long the length of that hypotenuse is. Well, this is definitely a job for a calculator. Switching screens again. 50 divided by this answer, and I'm just highlighting 0.422618 and bringing it down. Now there's more of the numbers. When I hit enter, I'm seeing more of that irrational decimal. That's fine. The more numbers you use, the more digits you use, the more accurate your answer is going to be. So when I do 50 divided by that irrational value, I get 118.31. 118.31. Now, if you rounded and you didn't leave all these numbers in here, you made something different in this final decimal. So I recommend that you try not to round. Okay. There's my final answer. Highlight that puppy. The hypotenuse that I'm looking for is 118.31. Told you it was new. So let's make sure you take a lot of time to soak it in as we work through these, okay? All right, next, I still want to stick with sine, but I want to try to find this angle measure this time. I know two of the sides. I want to find the angle measure. So remember, we're working with the opposite leg and hypotenuse leg, and I don't want to switch up the positions. But I need to find the angle. I need to know that the angle is equal to a value. Well, that's where the sine inverse comes in handy. The inverse of finding a side is finding an angle. We keep the opposite over hypotenuse pattern. So if I want to find an angle, I'm going to use the sine inverse function of the opposite and hypotenuse. All right, so let's set it up for this problem. Solve for the theta, solve for the angle of perspective. So the angle of perspective is using the opposite and the hypotenuse, which is your sine function. Sine inverse of the opposite value, 11, over the hypotenuse value, 20. All right, let's switch over screens to the calculator. I'll show you how to get that. In the trig button, the trig button by the 7, sine to the power of -1 is the inverse function. The inverse function solves for angles. I need a fraction, so I'm hitting Control Divide to put my fraction template in there. And I've got 11 in the numerator, 20 in the denominator, and I get 33.367. I'm going to round to the hundredths, which is 33.37. 33.37 when I round to the hundredth. Well, remember, guys, theta represents an angle of perspective, and angles are measured in degrees. So my final answer here is 33.37 degrees. Okay, that was our very first look at trig. Okay, we're going to keep going. I'm going to see what it looks like for cosine and tangent. But this was a good first step. All right, next we're going to look at cosine. I'm going to close this up so we don't have too much to look at. Cosine uses a different pair of angle sides. Okay, remember, sine uses the opposite and the hypotenuse. Cosine uses the adjacent and the hypotenuse. So that's the first thing we need to write down. Make sure you have in your notes. Cosine relies on the hypotenuse, always across from that 90-degree angle, and the adjacent side, the hypotenuse and the adjacent side. Okay, so when we're given information including the hypotenuse and the adjacent leg, that's when we're going to use the cosine function. As far as the setup and solve goes, it's almost identical to what we did with sine. So I'm going to open up this sine window again for a comparison. If we want to find a side value, and we're using the adjacent and hypotenuse, we're going to use the cosine function applied to the angle of perspective. And the comparison is the adjacent side over the hypotenuse. The adjacent side over the hypotenuse. All right, let's do this example. Cosine uses the hypotenuse, which is labeled x, and the adjacent side, which is labeled 8. Our angle of perspective is 40. So let's plug everything into the formula. Cosine of your angle of perspective, which is 40, is equal to the adjacent length, here that's 8, over the hypotenuse length, and in this example that's x. So the cosine uses the adjacent value over the hypotenuse value. Okay, my suggestion for solving is to make a fraction, make a proportion, and do some cross multiplying. Cosine 40 times x is equal to 8 times 1. That's how we cross multiply. Well, now I need to switch over and use my calculator to get a decimal value for cosine 40. So I'm switching screens here. Okay, trig button, cosine this time of 40. Cosine of 40 is 0.7660044. And I'm going to use all the decimals I can use so that I don't mess up any rounding. And screens back. .766044 replaces cosine 40. So we've got that value times x equals 8 times 1, and 8 times 1 is just 8. And now to get x by itself, I need to get rid of this decimal that's multiplying x. So to do that, I'm going to divide by 0.766044. All right, I'll need a calculator for that for sure. So 8 divided by our answer previously here in the calculator, the 0.766044 is actually a much longer decimal, and I'm just going to leave all those numbers in there to get the most accurate answer. I'm getting 10.44 if we're rounding to the nearest decimal place. 10.44. Final answer. 10.44 is the length of the hypotenuse. Okay. All right, let's do another. But this time, let's solve for an angle. It's still a cosine problem because check out the picture. We're still working on the hypotenuse and the adjacent side. If we're using these two sides, we're using cosine to solve. All right, well, to solve for an angle, that's when we use the inverse trig function. So I need the inverse cosine of the adjacent side over the hypotenuse. Adjacent over hypotenuse. So what will that look like for this problem? The angle value, theta, is equal to cosine's inverse of the adjacent value, which is 4, over the hypotenuse value, which is 7. 4 over 7. All right, switching screens over to the calculator. Cosine inverse, find it in the trig button. Cosine inverse of the fraction 4 over 7. That's a one-step problem. I'm getting a value of 55.15 if I round it to the hundreds position. And that is a degree measurement because we're talking about the angle here. So that is a degree measure. Final answer, 55.15 degrees. Okay, maybe it's starting to feel a little bit better by now. I'm sure it still feels pretty new. We only have one function left to go, and it's tangent. So let's recap one more time. Start from the top again. We're using sine when we're using the opposite leg and the hypotenuse. We're using cosine when we're given the adjacent leg and the hypotenuse. So the only other combination is if we're not given the hypotenuse at all. Let's open up this last flap. With tangent, we're never given the hypotenuse. The hypotenuse is a mystery. Instead, we're working with the opposite side and the adjacent leg. The opposite leg and the adjacent leg. Opposite leg and the adjacent leg forces us to use tangent to solve. Okay, from here, the setup is very similar. In order to find a side, we're going to use the tangent function of the angle of perspective. And here's the comparison. Jot this down correctly. Tangent uses the opposite side over the adjacent side. Opposite side in the numerator, adjacent side in the denominator. Tangent of theta is equal to the opposite over the adjacent. So let's try that here in our examples. Okay. In our picture, x represents the opposite side and 10 represents the adjacent side, while 33 degrees represents theta, the angle of perspective. So when we plug everything into the formula, I would have tangent of 33 is equal to the opposite value, which is x, over the adjacent value, which is 10. Okay, so we've recognized opposite and adjacent, which made us choose tangent. We've plugged everything into the right spot, and now we're going to solve. In order to solve, I recommend that you cross multiply. So put a 1 in, and let's cross multiply. This would be 1 times x equals tangent 33 times 10. All right, well, this is certainly where I'm going to need my calculator, so I'm switching screens. Trig button, tangent 33. Tangent 33 is 0.649408. 0.649408. So let's rewrite our equation. 1 times x is just x. Tangent 33 is 0.649408. And I need to multiply that by 10. Now you can grab your calculator here, or if you remember the trick on how to multiply by tens, all it does is move the decimal over. So this would be 6.49408. That's my final answer. Of course, if you want to round that, since we rounded all the others, it would be just 6.49. Final answer, 6.49. One final example to go. Thank you so much for hanging with me. I know this is new and I know it's difficult, so keep working on it with me here. Final piece. What if we're trying to find an angle when given the opposite side and the adjacent side? Okay. Well, let's check out the pattern above. What do we do when we're trying to find an angle when we're using trig? If we're using sine, we use the sine inverse. If we're using cosine, we use the cosine inverse. So when finding an angle, we're always using the trig inverse function. So even down here on tangent, we're going to use tangent inverse. Now tangent always goes with the comparison of opposite over adjacent. The opposite side measure over the adjacent side measure. All right, so let's see what that looks like in this example. Theta is going to be equal to the tangent inverse of the opposite measure over the adjacent measure. The opposite measure is 3. The adjacent measure is 5. So I'm going to switch screens and grab my calculator. Trig button, tangent inverse because I'm finding an angle of the fraction 3 over 5. If I round that to the 100th, as I've rounded all my others, that would be 30.96. 30.96. And what did we just solve for? We solved for an angle. So that is measured in degrees. 30.96 degrees is my final answer. I know this is a lot, guys, and I absolutely expect questions, so please do not hesitate to ask questions. Something I want to help you with to help you decide when to use sine, cosine, and tangent. Absolutely use your notes as much as possible, but there's a really quick little acronym that if you do any independent research, you are going to find this acronym out there. So I'm going to shut these little doors so I have somewhere to write. I'm going to put them right on the front here. The acronym is SOHCAHTOA. SOHCAHTOA. What on earth am I talking about? Well, so is sine is equal to the opposite over hypotenuse. So sine goes with opposite and hypotenuse. Cosine is equal to the adjacent over hypotenuse. So there's your and then TOA, tangent, is equal to the opposite over adjacent. TOA. SOHCAHTOA. Maybe that'll be a helpful way for you to remember. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. People have even made up silly little rhymes to go with it. This is the one I learned back in the day. Some old hippie caught another hippie tripping on acid. It's silly. It's silly, silly, silly. I'm sure some teenager made it up a long time ago and it's been passed through the generations. Whatever it takes for you to remember how sine, cosine, and tangent are different. It's all about the side pairs that we're using. Sine goes with the opposite and hypotenuse, cosine with the adjacent and hypotenuse, tangent with the opposite and adjacent. Happy studying. Come find me if you need anything at all.